Why does 0 factorial equal 1? It does seem to defy the logic of, say, 3 factorial, right? Because 3 factorial is 3 times 2 times 1, which is equal to 6, and 2 factorial is 2 times 1, which is 2. It does seem to go against that logic, right? Well, I'm going to argue, or I'm going to make the case that 0 factorial, the same way I would argue for this. A to the 0 is equal to 1. Because it's the same problem. When you say a squared, right? You're saying a times a. All you're doing is multiplying this number by itself this many times. So so that's where the logic breaks down, right? When we multiply this number by itself this many times, it doesn't seem intuitively, at least, to equal 1. But if we write it out, say we just picked a number for a, say we'll pick 2, and we'll say 2 to the first power is equal to what? Well, it's equal to 2. And if we keep going down, 2 squared is equal to 4, and 2 cubed is equal to 8, and 2 to the 4th is equal to 16, and 2 to the 5th is equal to 32. We could keep going, but for right now and to save time, we won't. Well, going forwards, I'm sure you've done this many, many times, but what about if you go backwards? Say, how do you get from 32 to 16? Well, you divide by 2, right? What about from 16 to 8? Divide by 2. From 8 to 4? Divide by 2. From 4 to 2? Divide by 2. What about 2 to the 0? Well, if we continue this pattern, because we have no reason to believe that it stops here, if we divide by 2, 2 to the 0 equals 1. What about 2 to the negative first power? Divide 1 by 2, that is 1/2. So, you can argue, we can do the same thing with this over here. What about, we'll start out with, say, we'll start out with 1 factorial, the same way we did 1 factorial is equal to 1. 2 factorial is equal to 2 times 1, which is 2. 3 factorial is equal to 3 times 2 times 1, which is 6. 4 factorial is equal to 4 times 3 times 2 times 1, which is 24. And we'll stop at 5. So 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Now if we work backwards the same way we did over here, to go from 120 to 24, well, we divide by 5, right? Because 120 divided by 5 is 24. So we divide by 5. We go from 24 to 6, well, we divide by 4. From 6 to 2, we divide by 3. From 2 to 1, we divide by 2. And from 1 to 0, we could divide by 1, right? So if we did 0 factorial is equal to what? Well, we divide 1 by 1, we still get 1. So I'm going to show you another way on how 0 factorial is equal to 1, and I'm going to do it through example. So with the first example, consider 3 letters A, B, and C. How many separate ways can A, B, and C be rearranged? Well, if we write them all out, let's just do that. A, B, and C, that's 1. A, C, B, that's 2. B, A, C, 3. B, C, A, 4. C, A, B, 5. And C, B, A is equal to 6. We could also figure this out by writing 3 factorial, because there's 3 letters, so 3 times 2 times 1, which is equal to 6. There are 6 separate distinct ways to rearrange 3 separate letters. Well, if we did it with 1 letter, so consider rearranging 1 letter, and we'll pick the letter A. If we wrote out every possible way to rearrange that letter, there's 1 possible way to rearrange 1 distinct letter. And we could do this by 1 factorial, and 1 times 1 is equal to 1. Well, this is where it gets kind of tricky. Consider rearranging 0 letters. How many different ways can this be done? So 0 letters, 0 factorial. How many separate ways can 0 letters be rearranged? Well, it turns out there is one way to distribute nothing. Think about it. How many separate ways can you distribute nothing to someone? There's one way to distribute absolutely nothing.